All right, how's everyone doing? Yesterday what we looked at were isosceles triangles. And we looked at a theorem that goes in both directions. We looked at a theorem that says if two sides of a triangle are equal, then the angles opposite are also equal. So in my first picture here, if AC equals BC, if those two sides are equal, notice the tick marks, then the angles opposite, so the angle opposite this side and the angle opposite this side, they're called base angles, the angles are going to be equal. And then we showed that the theorem works in the other direction as well, so now my second picture. So if the two angles are equal, then the sides across also have to be equal. So then LN and MN would have to be equal. So it's one of those theorems that works in both directions. Okay, so that's what we looked at yesterday. And now today I'm just going to do a couple of numerical problems, like I'm very likely to put on one of your tests, with isosceles triangles. So just as an example, here is a triangle. Let me give you a little bit of information about it. Get my pencils to work here. So I'm going to show you that those two sides are equal. And then I'm going to tell you this side is 14 long, this side is B. And then I'm going to tell you this angle is 70 degrees and this angle is 40 degrees and ask you for this angle. Okay, so hopefully it's going to be a nice easy problem. I'm going to ask you to find side B and angle A. And the idea is really simple. The tick marks show us that these two sides are equal. So if one of those sides is 14, the other side has to be 14 units long. No work to do, just observing that those two have to be equal. Okay, and if the two sides are equal, then our theorem says that the angles opposite must also be equal. So if the angle in the lower left-hand corner is 70 degrees, the angle in the lower right-hand corner has to be 70 degrees. Okay, so nice easy problem there. Let me give you, and by the way, make sure you pause the video anytime you need a little more time to get a problem down for your notebook. But here's another example. Gonna appear to give you less information this time. So here's another isosceles triangle, but this time instead of giving you, excuse me, instead of giving you two angles, I'm only going to give you one. So I'm going to call this angle right here, I meant to do that in blue, I'm going to give you this angle right here as being 72 degrees. And then I'm going to ask you for the other two. So I'll ask you for angle D and angle E. Okay, so with only one angle, can you find the other two? And the answer is yes, because the triangle is isosceles. The two sides are equal, and our theorem says if the two sides are equal, then the angles opposite must also be equal. So if I call this one angle F, just for the heck of it, if angle F is 72 degrees, then angle E must also be 72 degrees, right? The angles opposite the equal sides must be equal. And then once I know both F and E are 72 degrees, I can get to angle D, remembering that the three inside angles add up to 180 degrees. So I know that 72 degrees plus 72 degrees plus whatever angle D is would have to add up to 180 degrees. So I can solve the equation. 72 and 72 is 144. And move the positive 144 to the other side by subtraction. So angle D then would be 36 degrees. Okay, doing all right so far? Okay, again, feel free to pause the video to get a complete, to get your problem completed in your notebook if you wish. All right, I'm just going to continue to do a few more examples. So here's another example of an isosceles triangle. I'm going to tell you that these two sides are equal, and this time I'm going to give you this angle. I'm going to tell you that angle is 110 degrees and ask you for these two. I'm going to ask you for angle P and angle Q. So how do I find those two? Seems like it might be the same as the previous, but not quite. Okay, I'm only telling you one out of the three angles, but this time the one I'm telling you is called the vertex angle. So how do we find these other two? Well, once again, we use the fact that if the sides of this triangle are equal, that means that the angles opposite, the base angles, must also be equal. So whatever angle P is must be the same as angle Q. Alrighty? So whatever angle P is, let's just call it something nice and simple like X. Angle Q must be exactly the same thing. Right? And then using the fact that the three angles add up to 180 degrees, we'd be able to say then that X plus 110 has to equal 180 degrees. And that gives you a nice easy equation to solve. 1x plus 1x is 2x. Move plus 110 to the other side by subtraction. And get rid of times 2 by division. So the value for x is going to be 70 divided by 2, which is 35. And x belongs to both P and Q. So both of those angles then are 34 degrees. Sorry, 35. 35 degrees. Okay? And one final numerical problem with isosceles triangles. Again, isosceles triangle. So this side and this side are equal, but this time I'm not going to give you any of the angles. I'm going to tell you this angle is 4x, this angle is 4x, and that angle is 2x degrees. Okay, so in this one, if I show you that, let's call this one just for something different, capital X, capital Y. No, in fact, I better not use those letters. I should use something different. How about like T, U, and V? I could then ask you guys 4 questions. What's the value of X? How big is angle T? How big is angle U? And how big is angle V? Okay, so pretty easy, I hope, as long as we remember that the 3 inside angles of a triangle add up to 180 degrees. So we just need to simply say that 2x plus 4x plus 4x will add up to 180 degrees. And again, gives you a nice easy equation to solve. 4 plus 4 is 8, plus 2 more is 10x. And to get rid of times 10, we divide by 10. So the value for x then is going to be 18 degrees. And once we know the value of x, we can then go over to our triangle and put 18 in wherever we see an x, so that 2 times 18 would be 36 for angle U. 4 times 18 would be 72 for angle T, and 4 times 18 is 72 for angle V. And so our 4 values, 18, 72, 36, and 72. Okay? Alrighty. And then to finish this section off, we're going to have one more definition and theorem. And this time, instead of an isosceles triangle, we're going to be looking at a triangle that is, if I can get a decent picture here, there we go, is going to be a triangle that is not only isosceles, but equilateral. Okay, and just need to remind everybody of our definition. A triangle that is equilateral, the prefix means equal, and the word lateral means sides. An equilateral triangle is just going to be a triangle with 3 equal sides. Okay? Now, the other type of, the other term I should say that's important here is this one that we talked about a couple weeks ago. It's going to be for a triangle that's equiangular. Again, the prefix equa means equal, but this time the base word is angular, which of course means angles. So this, of course, is a triangle with 3 equal angles. All right, so we've had those definitions before, but our theorem, this is what I need you to remember, is that a triangle is equilateral if and only if the triangle is equiangular. A triangle is equilateral if and only if the triangle is equiangular. All right? So that's one of those theorems that works in both directions, meaning if it's equilateral, then it is equiangular, and it also works backwards. If we know it's equiangular, then it's equilateral. So we have a situation where all of the sides and all of the angles are equal. All sides are equal, all angles are equal. All sides, all angles are equal. Okay? Alrighty, so feel free again to pause the video to make sure you get that down into your notebook. One important result of this is if I have a triangle that's equilateral, we just said that that also means it's equiangular. And the important result I need you to come away with or to put into your notebook is that if a triangle is equiangular, all of the angles are equal, you can automatically find the angle measure for each of the angles. So if each of the angles has to be equal and the angles have to add up to 180 degrees, so two things have to be true at the same time. They have to add up to 180 degrees and they all have to be equal, then each individual angle must be, well, if you think about one of the angles being a variable, again, let's just be boring and call it x, then that means that all of the angles have to be x. So we'd know that x plus x plus x would have to be 180 degrees. 1x plus 1x plus 1x is 3x. And to get rid of the times 3, we'd divide by 3. So that means x, in other words, each individual angle must be 60 degrees. So anytime we ever have an equilateral, equiangular triangle, all of the angles must be 60 degrees. Must be 60 degrees. Okay? So if we were to ever give you a numerical problem then like the following, and I showed you that all three sides are equal, and then I told you one of the angles was maybe 4x big, could you then tell me the value for x? Right? Initially, you might think there's not enough information there, but there is. Because the triangle is equilateral, all three sides are equal, our theorem says that that means that all three angles must be equal. And what we just talked through, if all the angles are equal, then each individual angle must be equal to 60 degrees. So therefore, 4x must be equal to 60 degrees, which allows you to divide both sides by 4 and get the value for x then being 15 degrees. Okay? Or if I gave you a problem like the following, and I showed you in the problem that all three angles are equal, and then, excuse me, I gave you, let's call this side 5, and let's call this side y plus 1, right? Could you then find the value for y? The answer is sure, no problem, because if all three angles are equal, that forces all three sides to be equal. And then, of course, you can see it's very obvious after that. We could then set 5 equal to y plus 1 and then solve the equation. So the value for y must be 4. Right? So there's some simple numerical problems that we could give to you. And then finally, the last problem I'm going to do for you on this section, one last numerical problem. It's just going to take me a minute to draw you the picture, but we're going to start with a right triangle, and then I'm going to put in, let's see if I can do it well. Yeah, that looks pretty good. So I'm going to put in an extra line and then give you some information. This original angle was 90 degrees. These three segment lengths are equal to each other. And then also, that one is equal. Okay? And then some information here, This segment is 28. This segment is 28. This one is 4y. Okay. This angle right here is 2x big, 2x big. And then this angle right here is z big. Okay? And so what I'm going to ask of you is to find the value of x, the value of y, and the value of z. Right, so this is a good one to put into your notebook. So if you want to pause the video so that you give yourself a decent picture, and then turn the video back on and we'll work through the rest of it. Okay? So feel free to pause so you can get that done. Okay. So if you're back to solve this, there's a whole bunch of places where we could start. But I think I'll choose to ask you to start by just noticing that with all of the tick marks, we know all of those lengths are equal. So the two I'm going to ask you to focus on then are the 4y and one of the 28s. Doesn't matter which one of the 28s. So of course, since the tick marks are there, you know those have to be equal to each other, so that creates a very simple equation. We can divide both sides by 4, so the value for y is 7. So that one, pretty easy. Also, if you notice that this triangle that I'll try to outline in brown is equilateral, all three sides are equal. That means that it is also equiangular. And that means that this angle, 60 degrees, this angle, 60 degrees, and this angle, just being really careful which one you're looking at, is 60 degrees. Okay? And then I'd ask you to focus on these two angles, the 60 and the z. The 60 and this z. They're right next door neighbors. So whenever we have those next door neighbors like that, they're called a linear pair. And what I need you to remember is that a linear pair are two angles that always add up to 180 degrees. So 60 plus z has to equal 180 degrees, which allows you to move the 60 to the other side by subtraction, and therefore z must be 180 minus 60, or 120 degrees. Okay? And then finally, to get the value of x, there's a whole variety of ways to get there. I'm just going to choose one. I'm just going to choose one method, and that is, that if, the lower triangle that I could outline in, let's go with a different color just so it stands out a little bit. Let's go with purple. So if you look at this lower triangle that I'll outline in purple, it has two equal sides. So therefore it is isosceles. So the two angles across from the equal sides have to be equal. So if the angle in the lower left is 2x, the angle in the lower right is 2x. And then we can just simply use the fact that the three angles add up to 180 degrees. So 2x plus 120, remember that's what we got for z, has to equal 180 degrees. So 2x plus 2x is 4x. We move the plus 120 to the other side by subtraction. And we divide both sides by 4. So x is going to be equal to 15 degrees. Okay? Alrighty, so hopefully those numerical problems will help you out with your assignment. This is a little less than half of the class period to watch the video. So now use the second half of the class period to work on your assignment for section 4. Okay? So we'll talk to you later today or tomorrow. Have a good day.